So in this video we're going to be talking about polygons and how to work with polygons, what they are, anything like that. And to start off, we're going to first talk about what a polygon even is. A polygon is a two-dimensional shape. It means it's flat. A two-dimensional shape that has three or more straight lines. And that part's important. Polygons do not have curves or bends in it anywhere. They are only made up of straight lines. Now the first type of polygon to talk about is a regular polygon, and it's a polygon where all of the sides and all of the angles are congruent. So think about things like equilateral triangles or squares or stop signs, those octagons, anything where it is perfectly symmetrical, perfectly congruent all the way through the shape. Then you have the irregular polygon. And an irregular polygon is where there is at least one side or angle that is not congruent to the rest of the shape. So think about a rectangle. Even though a rectangle seems like it's a pretty normal shape, the fact that there is something that is not congruent means that it is technically in a regular polygon. From there we can talk about two kind of subsets, the first being a convex polygon. And a convex polygon is a polygon that doesn't dent in. So our first two shapes that we can look at is the square and the octagon. These are both not denting in anywhere. Anywhere that there's a vertex, it's always pointed outwards for the square. And again, anywhere that there's a vertex on this octagon is pointing outwards. It's not dented inwards at all. Now these are both considered to be regular polygons because they're symmetrical, they're congruent all the way around. All regular polygons are convex polygons, but even some of the irregular polygons can be considered convex. Even though this shape is not symmetrical all the way around, you have very different sides going on. Even though it's not symmetrical all the way around, it still is considered convex because at no point does it actually dent in to the shape. Everything is pointed outwards. So this is a convex irregular polygon. The other type of polygon is a concave polygon. And a concave polygon is a polygon that dents in. So if we look at these shapes, everywhere on them is a point that you can look at and say, well, this is denting into the shape. It almost looks like somebody took a baseball bat to it and dented the shape inwards. Concave polygons are never regular. You'll never see a regular polygon that's concave. They will always be irregular because there is one of the angles that's dented inwards. It's throwing the shape off. So convex polygons will always be regular. Sometimes they'll be irregular. Concave polygons will never be regular. They're always irregular polygons. And again, the name kind of helps you here too. A concave polygon looks like it's been caved in, like somebody hit it with a baseball bat. So that's the overview of what polygons are, and then we can get into actually how to work with these polygons. So the first thing we want to look at is something called the interior triangle theorem. And what it says is that for any polygon that you can think of, for any polygon, however many sides that there are, in the number of sides, there are n minus 2 triangles that actually fit inside of it. So if we look at the shape that's next to this definition, this shape has 8 sides to it. If we pick one of the vertices on here, I can draw 5 lines in there, creating 6 non-overlapping triangles. So this 8-sided shape can perfectly fit inside of it 6 triangles. So the interior triangle theorem, however many sides are in the shape, you can fit that number minus 2, that many triangles inside of that shape. So an 8-sided shape will always be able to fit 6 triangles inside of it. Then we have the interior angle sum, which says that a polygon's interior angle measure is 180 times n minus 2. Now if we think about that for just a second, The interior angle sum is 180 times n minus 2. Well, what is n minus 2? N minus 2 is the amount of triangles that are fitting inside of the shape. Well, what is 180? 180 is the amount of degrees inside of a triangle. So what we're basically doing is we're taking each of these triangles and we're taking their measurements and we're just putting it all together. There's 6 triangles, so there's 6 180 degrees sitting inside of that shape. So if we look at our blue shape here, this blue shape has 8 angles inside of it. The interior angle sum says that if I take all 8 of those and I add them together, it's supposed to equal a number. Well, that number is 180 instead of n minus 2, 188 minus 2, so 180 times 6. So every single one of those angles, if we add them together, every single one of them is 1,080 degrees. So the interior angle sum, just like a triangle adds up to be a 180, an interior angle sum says whatever shape you're looking at, it has a measurement, just like a triangle, that it adds up to. And this formula, 180 n minus 2, this formula tells you for any shape what its measurement is supposed to be. Triangles are 180, and 8-sided figures are 1,080, and it'll tell you what a 100-sided figure is. Doesn't matter. And what this formula is doing for you is it's basically taking all of the measurements that you don't know, adding them together, and telling you what that sum is supposed to be. Now, we've looked at how to split a shape into triangles, how to use that to tell you what the interior angle sum is, but what if we just wanted to find an individual angle measurement? Well, that's where this last formula comes in. To find an individual angle, the measure of any angle, it's 180 times n minus 2. Well, that is literally the measurement that we just did in blue. 180 n minus 2 divided by n. So you're basically finding out the interior angle sum, and then whatever number that is, you divide it by however many sides there are. So for this shape, it's 188, the amount of sides, minus 2, divided by 8. Which means that each and every individual angle in this shape adds up to be, or is, 135. Now this only works for regular polygons. Because you are equally dividing whatever the measurement is, 1080, you're equally dividing it by 8. Which means it has to be a regular polygon that you're doing it to. Because if it's irregular, the angles don't divide up equally. Now, this seems like a lot of formulas, but if we look at it carefully, it's really not that many. We have 1 at the top, n minus 2. That one formula, we multiply it by 180. And then this formula, we divide it by how many sides that there are. You really only are memorizing one formula. It's just used in 3 different ways. You find the amount of triangles inside of the shape, multiply it by 180, and then divide it by however many sides there are. That's it. One formula, just talked about in 3 different ways. So for our first problem, Jenna is building a corner cabinet to fit inside of a rectangular room. If she builds it with the angles that are shown, the one in pink, she wants to be able to determine, can it fit in the corner? So it's a rectangular room, and she wants to be able to tell if this cabinet is going to fit perfectly inside of this rectangular room. Well, if it's a rectangular room, rectangles have 90-degree corners. That means we need to figure out if question mark is going to equal 90 degrees. Well, how do we do that? Let's look at how many sides this shape has. It has 1, 2, 3, 4, 5 sides. Which means the interior angle sum here is 180 times 5 minus 2. So 180 times 3. Which is 520 and 40. Now we know 4 of the angles, 90, 90, 135, 135. So 540 minus 135 plus 135 plus 90 plus 90 means that the leftover measurement is 90 degrees, which is exactly what we're looking for. So because the final shape is 90, and because a rectangle has a corner that equals 90, then that means the cabinet will fit. So for these three, the first one, what is the interior angle sum of a 17 gon? That means a 17-sided shape. So 180 times 17 minus 2, 180 times 15, which is 2,700. Number 2, the interior angle measurement of a regular n-gon, so a shape that we do not know, has a measurement of 3,780. How many sides does it have? So 180 n minus 2 is equal to 3,780. And so we need to solve for n. So first step here, so we need to divide by 180. So n minus 2 is equal to 21. And now n minus 2, if we add that 2 to the other side, that gives us n by itself being 23. So this shape has 23 sides. And lastly, each angle of a regular n-gon measures 172.8. How many sides does the n-gon have? So 180 n minus 2 over n is equal to 172.8. So whenever you have a fraction on the bottom, the best thing you could do is take the equation and multiply both sides by n, because these are going to cancel each other out, leaving you with 180 n minus 2 is equal to 172.8 n. From here we could do one of two things. We could first just divide out the 180, or secondly, we could distribute it into the parenthesis that it's next to. Doesn't matter which route you go, I'm going to distribute it. So that gives us 180 n minus 360 is equal to 172.8 n. Now I need to get the ends to one side. So I'm going to subtract 180 on over to the other side, 180 n. And this gives us, so we go over to the side, this gives us negative 360 is equal to negative 7.2 n. And so then our final step here would be to divide out negative 7.2 on over to the other side. So n is going to equal 50. So this side has 50, or the shape has 50 sides to it. So for this, we want to look at what are the exterior sums of the following two regular polygons. So regular means everything about it's congruent. That means that this is an equilateral triangle, which means each of these angles here are 60. Well, if each of these angles are 60, 180 minus 60 is 120. So these exterior angles are 120. And if we remember from last chapter, exterior angles are the ones that are supplementary to the interior ones. They add to be 180. So 120 added 3 times gives me 360. If we look at this square, Squares have angles of 90, which means that the outside angles here are 90. And if we add up 90 4 times, that equals 360. Now, what if we did a regular pentagon? We'll just kind of sketch it out here. If we did a regular pentagon and we looked at its exterior angles, a regular pentagon, each interior angle, 180, 5 minus 2 over 5, that equals 108. So each interior angle is 108, meaning that each exterior angle would be 72. And if we add up 72 5 times, that gives us, again, 360. So every single time we add up these exterior angles, it's giving us 360. So what is the sum of the measure of a convex 17gon of the exterior angles? Well, based on what we just did, it's got to be 360. Which leads into this next definition, the polygon exterior angle sum. The exterior angle sum of any polygon is always going to be 360. If we think about y for a second, let's look at this Desmos slide that we have. So what this Desmos slide is showing us is, first, this n number, that's the number of sides, and we can see it in blue on the shape. So this is a 3-sided shape, a triangle. The next number is showing us the interior angle sum, so a triangle always adds to be 360. Then it's showing us what each interior angle is, in this case 60. The exterior angle, so 180 minus 60, which is 120. And then the exterior angle sum, which is 120 times 3, because there's 3 of them, that's 360. Now, as we increase the number of sides, these numbers are going to change, and we're going to watch how it changes. So as we go to 4, the interior angle sum is now 360 instead of 180. The interior angles are 90 instead of 60. The exterior angles are 90 instead of 120, and the exterior angle sum is still 360. So the interior angle sum and the interior angle, both of those increased in size. The exterior angle decreased, but the exterior angle sum stayed the same. We go up to a pentagon, 5 sides, the interior angle sum is 540, so it increased. The interior angle 108, it increased. The exterior angle 72, it decreased, but the exterior angle stayed the same. And we see as we keep increasing, this pattern is still tracking the exact same way. So as we're up to 25, so this 25-sided shape, the interior angle sum is this massive number now. It's 4,140. Each individual angle of this shape is 165.6 degrees. Each exterior angle is a very small 14.4 degrees, but the sum is still 360. And as we increase this to a much larger number, like 10,000 sides, or if we go even more extreme, like 10 billion sides, what we see is that this polygon has essentially turned into a circle. And as this polygon basically turns into a circle, the interior angle sum gets closer and closer and closer to what is basically infinity. Each interior angle gets closer and closer to 180, which 180 is a straight line. So the difference between one side to the next is almost not there at all. The exterior angle gets closer to closer to what's basically 0, and the exterior angle sum is still 360. So no matter what size shape you're looking at, as you increase the amount of sides, the interior angle sum gets incredibly big, but the exterior angle sum is still always 360. And so this is why a circle has a degree measure of 360, because adding up all the sides will always still give you 360 around it. So we're going to take that, as a little side tangent, we're going to take that and we're going to apply it to our first problem. So given a regular pentagon, keyword there is regular, given a regular pentagon created by intersecting rays and lines, what is the measure of x? Well, if this is regular, that means everything in it is congruent. And on our last slide, or 2 slides ago, we actually solved this, but we're going to do it again. 180, if it's a pentagon, 5 sides, 180, 5 minus 2 over 5, which gives us, not 540, 108 as our individual sides. So each side here is 108. Which means if this is 108, then over here, this must be 72. So 9x is equal to 72 degrees. So x is equal to 8 when you divide it by 9. So that's one route to go to it. But there's a different route we could go. And let's put option 2 here. All of these angles, as we just talked about, have to add to be 360. So that means if we take 360 and divide it by 5, because there's 5 of them, 360 divided by 5 is 72. So then from there, 72 must equal 9x. Divide out the 9, we get 8 again. So we could focus inside and build outwards, or we could just go straight to the outside and set 9x equal to whatever number we get. So given that the irregular hexagon created by intersecting rays and lines, what is the measure of x? So irregular, that means we could figure out the sum of the inside, but we could not figure out the individual angles because they're all different. But what we can do is we have all the exterior angles, and all the exterior angles must add to be 360. So 20x plus 8x plus 10 plus 6x plus 19x, and then we'll write it a little bit smaller so we can fit it on. So plus 9x plus 5x plus 15, all of that must equal 360. So if we combine our like terms, 28, 6, negative 9, or 19, 9, and 5 gives us 67x plus, and then 10 and 15 would be 25. All of that equals 360. So then if we subtract the 25, 67x is equal to 335. And then if we divide out the 67, we get x is equal to 5. So we may not be able to find the individual measurements, but we can find the exterior measurements because they all have to always be 360. Which, now that we know what x is, we could plug it in. So 20 times 5 here, for example, would be 100, which means this would be 80. And so then we could go through the rest of it and do the same thing and actually come up with those inside numbers. All right, so suppose that angle 1 and 3 are congruent. So angle 1, put 2 arcs, and 3 are congruent. Angle 4 is also congruent, so put 2 arcs here, and angle 6 is also congruent. And then 2 and 5 are congruent to each other, so we'll just put 1 arc between 2 and 5. And angle 3 has the measurement of angle 2 plus 30. Alright, so we know all of them have to add to be 360. We don't have any actual numbers. But we do know 4 of them are equal to each other. The other 2 are equal to each other. And one of them is based off of a different angle plus 30. So angle 3 is equal to whatever angle 2's value is plus 30. which means we need to make angle 2 an x. Because angle 2 is just sitting there. Angle 3 is based off of it. Whenever you have a number that other numbers are based off of it, that number has to become an x. So angle 3 is x plus 30, which means angle 2 and angle 5 are x. So x plus 30, x plus 30, and then x plus 30, and x plus 30. So now we actually have all of our measurements. And they all have to add to be 360. So x plus 30, 4 of them, plus 2x's, that has to equal 360. So if we distribute that, 4x plus 120 plus 2x is equal to 360. 6x plus 120 is equal to 360. If we subtract 120, 6x is equal to 240. And then if we divide out the 6, x is going to be equal to 40. Now if we read the question carefully, it doesn't say what is x, it says what is angle 4. So 40 plus 30, let's do it this way, angle 4 is equal to 40 plus 30, which is equal to 70. There's your answer. So we're going to figure out what is the value of x in the pentagon shown. So pentagon, 5 sides, 1, 2, 3, 4, 5. Yep, so 180, 5 minus 2. Write that a little lower, 180, 5 minus 2, and that's going to be equal to 540. So this is an irregular pentagon. You can see it because the side measurements are all over the place. So we cannot get an individual angle size, but because we have the sum, 3x plus 4 plus 7x minus 3 plus 6x plus 12 plus 6x minus 3 plus 90, all of that has to equal 540. So once you get the sum, you can add everything to it. So from here, we're going to combine like terms. So we have a 3x, a 7x, a 6x, and a 6x. So together, that gives us 22x. And then we have 4 minus 3 plus 12 minus 3 plus 90, which gives us 100. So 540 is equal to 100. If we subtract that 100, we get 440 is equal to 22x. And then if we divide out the 22, we get 20 for x. For our next problem, a convex polygon can be decomposed. That means broken into or split up into, can be decomposed into 47 triangles. How many sides does the polygon have? So if it can be broken into 47 triangles, that means n minus 2 gave us 47, which means adding 2 gives us 49 for the total sides that we have. The measure of each interior angle of a regular 100-gon, 100-sided shape is 3x plus 26.4. What is the value of x? So the measure of each interior angle of a regular, that means it's all congruent. That means we can use 180, 100 minus 2 over 100, and that gives us 176.4. which means 176.4 is equal to 3x plus 26.4, which then we we subtract 26.4 to the other side, which gives us 150 is equal to 3x, and then we divide out the 3, and we get 50 being the value of x. Okay, we're going to figure out the measures of x and y. Y here is going to be the easier one to start with. This shape, if we look at it, 1, 2, 3, 4, 5, 6, 7 sides, but it's not a regular polygon, so the most we can do with that is figure out the interior angle sum. So 180, 7 minus 2, which is 900. And so that means 900 is equal to 135 plus 140 plus 150 plus 120 plus 135 plus 120 plus y, which means 900 is equal to, adding these all together gives us 800 plus y. So if we subtract that, y is equal to 100. And x is an exterior angle to that, so 180 minus 100 jumps us out to where x is, which is 80. And lastly, we have the sum of the interior angle of a regular polygon is 6,120. What is the measure of each interior angle? So it's a regular polygon, 6,120 is its measurement. So that means that 6,120 is equal to 180 n minus 2. This is going to tell us how many sides there are. So if we divide out the 180 first, that's going to give us 34 is equal to n minus 2. And then if we add the 2, we have 36 sides for this shape. So the interior angle sum is 6,120. Each side is, or there's 36 sides in the shape, so then if we just take the interior angle sum and divide it by how many sides there are, that tells us that each and every angle is 170 degrees. Or you could take the amount of sides, 36, and put it back into the individual angle formula, 180 n minus 2 over n, and come up with the same number. And for B, what are the measures of the angles of angle 2? So this angle here, what are the measures of angle 2 for the polygon that is shown? So this polygon has 5 sides, and as we've already done before, it should come out to be 540, but we're going to double check it. 5 minus 2, and that does equal 540. So that means 3x plus 10 plus 2x plus 5 plus 3x plus x plus 15 plus 4x minus 10, all of that adds to be 540. And if we combine our like terms, we get 13x plus 20 is equal to 540. If we subtract 20 away to the other side, we get 13x is equal to 520. And if we divide out the 13, we get x is equal to 40. So if we plug that in, 4 times 40 minus 10 is 150, which means 180 minus 150 gives us 30. So angle 2 is equal to 30 degrees. And the last thing to talk about to finish this off is the names for the different polygons. So if it has 3 sides, we call it a triangle. Could also call it a trigon, but we are typically used to calling it a triangle. If you have 4 sides, it's quadrilateral. Again, you could call it a tetragon. Tetra meaning 4. Think of the game Tetris. The tetra there means 4-sided shapes. So quadrilateral is what we know it by, though. If you have 5 sides, it's a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. You might also see it as an enneagon. 10 sides is a decagon. 11 sides is a hendecagon. And 12 sides is a dodecagon. So 1 through 8, or 3 through 8, are mostly, except for hept, are mostly ones that most people have heard of before. Heptagon is the one that kind of sneaks in there. Most people don't deal with a 7-sided shape. After you get past 8, nonagon is 9, but then decagon, that decagon is used for the next 10 polygon sides. And it's kind of easy to remember, because remember, decade means 10 years, decagon means 10-sided shape. So a hendecagon is 1 past 10. A dodecagon, 2 past 10. And do, think of like dose or duo or anything like that. Do just means 2. And then as we get into the next column, it's basically a repeat of the original column, but with decagon attached to everything. So a tridecagon is just a triangle, but with decagon at the end. 3 past 10. Tetradecagon, again, it's just carrying that word over. Pendecagon, hexdecagon, heptadecagon, octadecagon, enneadecagon, and then you have the icosagon, which is when you get to 20. So 1 through 12, probably need to know it, but then once you get past 12, the rest of it is just copying it. If you're looking at 15 sides, well, 5 sides was a pentagon, so 15 is a pendecagon. So they aren't too hard to remember if you just remember to follow with that word, decagon.